Hello, everyone, and welcome to Discovery's Chats with Changemakers. I'm your host, Kavya, and I'm a high school junior in New Jersey, and I'm also a member of SWE Next, which is the Society of Women Engineers Leadership Program for high school girls. And every month on the show, I chat with a different guest from the STEM community. How does a candle burn? Why does ice cream melt? These are all questions that fascinated me when I was younger. So it's no surprise that I became interested in chemistry, which continues to stimulate my interest to this day. And that's why I'm super excited to be chatting with today's guest, Francisca Ogundele, a chemical engineer at Shell. Francisca, welcome. We are so excited to have you join us today.
Hi, Kavya. It's great to be here. Really looking forward to the conversation.
Definitely. And I'm going to be asking Francisca a few questions to get to know a little bit more about her. And if you have any questions, you can type them in the Q&A box below, and we'll save some time in the end to get to as many as we can. And also be sure to stay tuned until the end of today's session, where we will introduce a hands-on engineering challenge that you can try at home. So, Francisca, without further ado, let's get started. As a chemical engineer at Shell, could you please tell us a little bit more about your role and any current projects that you're working on?
Yeah, sure. So in my current role, I'm a project manager, and I manage projects that happen on some of our platforms out in the Gulf of Mexico in deep water. So these platforms, they're producing oil and gas 24/7. And occasionally, the folks that are living and working offshore, they have some ideas for some projects that they want to do. And these projects are either to make things more reliable, to make them safer, maybe to help them produce more oil and gas, or quite frankly, something just breaks and they need help to fix it. So if that solution to help resolve their problem needs a specific engineering solution, my team comes in to help support them and get the job done.
That's awesome. And we would love to hear a little bit more about how you first became part of the industry. So, what inspired you to pursue a career in chemical engineering?
Um, I think the two biggest inspirations for me to go into chemical engineering, one is my dad. He is a materials engineer, and so he was a very strong influence growing up, just understanding what engineers do and that it was something that was capable of being within my reach, right? It wasn't something new. But I think what really did it was at the time that I was applying for colleges, I went to a particular one in Toronto, and during one of the presentations, there was a young lady there who was an engineering student, and she looked just like me. Yeah, a young Black girl. And just seeing her in that space in the college, talking about engineering and what they did in the programs, I saw myself in her, and it again reinforced that this was something that was accessible to me and that I could do. And I think that was really the catalyst that said, "Hey, I'm going to sign up for an engineering degree in college."
That's interesting how role models especially inspired you to pursue a career in that field. And so, how do you not only find your passion, but keep your passion ignited, which is usually a lot more challenging?
Yeah, good question. So I think I really have a passion for solving problems. Yeah, why do things work the way they do? And once I understand how they work, how can I solve a particular problem to make people's lives easier, make things work better? But what keeps that passion alive is the people that I work with in resolving some of those really complex problems. So I work with a lot of great people in Shell, and I have a really great team.
That's wonderful to hear. And I know that before you had mentioned about how you led the installation of deep water systems in places like the Gulf of Mexico. So, what exactly is a deep water system and how is it important for the energy industry?
Yeah, so a deep water system, there are any structures that are either sitting on the top of the sea or sitting on the seabed floor where the water depth is at least 1,000 feet or more. Once you get to about 5,000 feet, we call that ultra deep water. Why they're important is a lot of the oil and gas resources out there are in some really remote places that are difficult to get to with just say a really long pipeline from onshore. And so we build this infrastructure out there to make it easier to go and get some of these resources out there. And so it's important for the energy industry because being able to access those resources lets us continue to provide an energy resource to the world.
Wow, that's pretty cool. I didn't know that before. And I think it just shows how engineering can help us access resources that maybe we might be limited towards. So that's pretty cool. And I would like to talk a little bit more besides the projects about your job in general. So you've traveled around the world for your job and even lived in China for a while, which sounds fascinating. And what is the most surprising lesson that you have learned from traveling all over the world? And has that influenced your perspective as an engineer in any way?
Yeah, so I grew up in Canada, and when I started working for Shell, in my career so far, I've had the privilege of living and working in 4 different countries across
Mhm.
3 continents. And I don't know if it was a surprise, but I really learned the value of understanding a particular country's history and how that influences the people today and what they do. And understanding that history from their perspective gives you more insight into their culture and the way they do things. And I think once you understood that history, that culture, being able to interact and work with people from different countries just makes the work go smoother, get things accomplished smoother. But it takes a lot to build those relationships, and understanding the history and culture is really important. And so as an engineer, where we're working with different people all the time, different disciplines, and particularly in my role, even though I'm based in the US now, I'm constantly working with people around the world to deliver things. But understanding how that particular culture is in a different country helps me to approach problems that are um, quite complicated, but I can always get the answers because I'm doing it from their perspective. I'm communicating with them on their, you know, with their perspective.
And I think you mentioned a lot about diverse collaboration, how you have to work with different people from different cultures, countries, and disciplines. And that actually perfectly leads on to the next question. So, as we know, chemical engineering interacts with many sciences and disciplines. And so, I was wondering if you could please tell us about a time where you worked on a multidisciplinary project and what role did you specifically play in that?
Yep. That's every day in every project that I do. So as a project manager, I like to say my main job is herding cats and directing traffic. So it's essentially getting, groups of different engineers, process engineers, mechanical engineers, electrical engineers, and they all have a role to play in delivering a project. And so most of my job is making sure that I'm getting those right disciplines in the room, talking together to help resolve whatever the problem is that we're trying to do. But even as an engineer and having the group of multidiscipline engineers, we can't forget that there's other folks in the company that help us do what we need to do. So I'm working with finance because they get us the money that we need to have to do the project. I work with people in contracts because when we need to buy things, they're the ones that help us out. I work with people in health and safety because they help us make sure that what we're delivering is safe and will work. So not just engineers, but just a multidisciplinary team that goes across the board is who I work with every day.
That's awesome. And as a project manager, I'm sure that there's sometimes challenges that arise in the project. So, do you have any philosophy that you stick to help overcome those challenges?
Yeah, my number one rule to my team when a challenge comes up is don't freak out. It's not the end of the world. Um, and I always say, let's go back to what the objective of the project was. Do we remember why we're doing this? And if you know why you're doing it, then we can adjust and do things differently that still help us accomplish that objective so we can deliver, to our customers. I think if we don't have that clear objective, then how do you know that all the changes that you're going to need to make to address the challenge are actually going to help? So I think those are my two guiding rules. Don't freak out. and do we remember what we were trying to do?
Definitely. You want to understand the problem with certainty and make sure that you clarified everything before trying to work on a solution. So that's
Yeah.
great. And we have our first audience question from Mrs. O'Connor's class. And the class has asked, how has your line of work changed with the demands for sustainability? Which I think is a really good question.
Yeah. So in Shell, we have a strategy called Powering Progress.
Mhm.
And it's about delivering more and cleaner energy solutions to the world. And under that strategy, we have an ambition, a goal to reduce our carbon emissions in what we produce and what we use by 50% by 2030. And so, how that influences what I do day to day is typically when you're deciding whether or not you want to do a project, you're looking at, how much is it going to cost? How long is it going to take? But the other thing that we are starting to look at for big and small projects is, well, what are the greenhouse gas emissions for that project? If I did this, how much energy am I going to consume to do this project? Or how much will this project, have greenhouse gas emissions? And that could actually be a deciding factor on whether you decide to do one thing over the other. And so that's probably one of the influences about sustainability related to our strategy that I'm seeing day to day.
Awesome. And in what ways do you think your job encourages you to be a change maker?
Um, so I remember reading a quote once that asked, are you willing to change what you're doing, even if it had made you successful in the past? And so I'm working with a team that's been around for quite a while. We've been delivering projects for a long time, but we're constantly having to change what we're doing, looking at how we can make things more efficient and faster or easier. And sometimes that means we have to take risks. So we have to be willing to try something, have it not work, and then go back to the drawing board and try again. And so I think that attitude of being willing to try something, take a risk, being okay with falling flat on your face, but getting up and trying it again, I think that's really what defines a change maker.
Definitely. And we often think that in engineering, everything is successful and there's not that many failures, but obviously you have to keep embracing change, new opportunities, new technology, because that's the only way to move forward. So thank you for explaining that. And finally, what is one development that gives you hope for the future of the energy industry?
Um, let's see. I think one development back to sort of that change maker question is I'm really proud of the way Shell has been embracing the changes in sustainability. Really driven by what society is expecting of businesses and corporations. Companies can decide to just kind of keep doing the same thing, but if we kept doing the same thing, I don't think we'd be around for very much longer. And so I think that willingness to change and adapt um, to make sure that we're continuing to meet society's expectations, that really gives me hope for the future. And I think what it's done is it's starting to then attract new and different talent for people who might not have thought about the energy industry. But I think with this increased focus on sustainability and the very specific actions we're taking to meet that, we're getting a lot of new and fresh faces. So part of my job, I also do interviews for new graduates coming into Shell. And that's probably one of the number one questions that they ask me. And so being able to respond with how we're changing to meet that demand, I think is gives me hope for the future.
Great, and that's a wonderful way to wrap up talking about your career. So now we want to take a step back, and I was just wondering, how did college prepare you for chemical engineering?
How did college prepare me for chemical engineering? So I think you've got the basic fundamentals, right? Going
Yeah.
to your classes, learning how things work, the basics of chemical processes and concepts. But I think what really helped me for preparing to enter the industry as a chemical engineer was the problem solving. Um, so just how do you frame a problem? How do you go about seeking solutions to that problem? How do you go about testing it? That really prepared me well for the work that I've been doing with Shell. But I think the other thing that it prepared me for was that a lot of the work that we were doing in college was group work. So just learning to work with other people, learning their work styles, having to adapt my working style to work with the group, that really prepared me for the work I do now, because all of my work is group work. So those are probably the two big things: problem solving and working in groups.
Definitely. And I think those soft skills that you mentioned are also really important besides the technical skills. That's like one recurring theme I've been hearing. So thank you for that. And what are some other types of jobs offered to chemical engineers?
Oh, it's what type of jobs can't chemical engineers do? So, um, I mean, you could go into food and beverage, food and drink. You could biomedical engineering, cosmetics, nuclear industry, chemical processing and manufacturing, teaching. I mean, there's lots of things chemical engineers could do. I remember when I started college, I was convinced I was going to go into food engineering, where my goal was to make my own ice cream flavor. That's what I wanted to do. But by the sort of nearing the end of college, I started to become really interested in biomedical engineering. And so I thought that's what I was going to do. But then, when I started applying for jobs, I ended up in oil and gas. But even with all the same classes and types of work I was doing in college, it had prepared me to enter any one of those areas.
And in thinking of the students who are joining us today and in the future, what is one piece of advice that you would give to your younger self?
Piece of advice I give to my younger self. I think I would tell my younger self to ask, don't be afraid to ask questions. When I was in elementary and middle school and even through college, I was really afraid to ask questions when I didn't understand something. Because I think I was afraid, oh, people are going to think this is a silly question, or she doesn't understand what's going on. Um, and so it didn't really help, because then I would try to do some work and I couldn't get the answer, or really I could have just raised my hand and asked the question. And so I think I would encourage anyone at any age to be comfortable with asking questions and saying, I don't know, because one, chances are somebody else also has the same question. So you're not just helping yourself, you're helping someone else. And how are you ever going to learn if you're not, asking those questions? And so even today, I'm not afraid anymore to say, hey, I didn't understand that. Could you explain it again? And I might ask the same question multiple times, but that's okay, because I'm going to keep asking until I get it. So that's what I would tell my younger self. Don't be afraid to ask questions.
And we have another audience question, and Keely wants to know, what is the most important skill or skills that an engineer should have?
Good question, Kelly. Most important skills. I think it's, I would say, being curious. So sort of back to asking the questions, really, really being willing to say, hey, how does this thing work? Why does it work the way it is? And then going, well, now that I understand that, what problems can I solve, with that? So I think curiosity is the biggest, I think one of the most important skills an engineer can have, because we only start solving the problem when we start being curious about what the problem is. And I think that requires also being humble, saying, I don't know, but I'm going to go out and try and find the answer.
That's wonderful. And I think we may know the answer to this question, but when you were in middle school, what did you want to be when you grew up?
Uh, I think I wanted to be a writer. There was probably a basketball player ambition in there. At some point, I wanted to be a doctor. Actually, in elementary school and middle school, engineering was not on my radar, quite honestly.
Mhm.
Like I said, my father was an engineer. I knew what they did, at least seeing what he did. That's what I thought all engineers did. But it wasn't necessarily something that I was like, oh, I'm going to be an engineer. And really, I think though, at least it was something that I was constantly exposed to. And that's eventually how I ended up in it. But no, I wanted to be, I think, everything else, but an engineer initially.
That's wonderful to hear. And what would you tell kids who aren't so sure about engineering or who may feel that they're not cut out to be an engineer?
Um, I think there, a lot of people think, hey, you got to be a genius at math and science to go into engineering. And, I'll be quite honest, math wasn't super easy for me
Hmm.
when I was younger, but, I liked it enough that I kind of stuck to it and could get through it. But I think, like I said, if you're curious about how and why things work, that's I think the first spark to think about engineering. But going beyond just being curious, it's kind of asking yourself, well, now that I know how this works, how can I use it to solve a real world problem? you know so if you find yourself asking like, hey, what's the problem that needs to be solved? Who do I need to solve this problem for? Who's it impacting? And then why is the problem important to solve? And if asking those questions and finding the answers to that gets you excited, then engineering is totally the thing for you, because that's literally what we do every day. And the math and the science and the work, that just gives you like the basic foundation. But I think you need to know, you know, that stuff, but the curiosity is really what's going to make the difference.
I think that's a really powerful message for our viewers today, just telling them to keep asking questions and exploring and staying curious. So that's great. And now we're going to skip to some more like fun questions. So, what do you like to do for fun outside of your work?
Outside of work, so I like hanging out with my family. So I'm married
Mhm.
and I got two kids. And so we like traveling and doing things as a family. I really enjoy reading. So my trusty Kindle is never too far from me. Um, and probably most recently in the last year, I think I've developed a healthy addiction to houseplants. So taking care of houseplants is like my new thing.
That sounds really fun. And another fun question, if you could have any superpower, what would you choose and why?
Okay. Uh, I think I would like the ability to fly. Um, I think it would help you get out of some sticky situations, and it's probably a great way to avoid traffic. So I think I would want to be able to fly.
Definitely. And we also have another audience question from Mrs. Streisberg's class, and they want to know, what does a day in the life of a chemical engineer look like?
A day in the life of a chemical engineer. Um, Well, I'll tell you that my first activities as a chemical engineer when I joined Shell, and this is probably not typical, but really interesting. So my first job in Shell as a chemical engineer was actually working offshore on one of our platforms.
Mhm.
So every 2 weeks, I would wake up really early and I would go to the heliport and I would take a helicopter out to the platform, and I got to live there for 2 weeks at a time, working with the people out there. And so I would wake up at 5 o'clock in the morning. And one of the first things I would do is we had all of our processes trending on a computer. So I would go and I would look at the trends and see if everything was running as it should be. And if there were any weird bobbles happening, I kind of made a list. Okay, I need to go check on that. And then I would actually go out on the deck, right? on the structure, and I would, hey, if I saw something going on with a pump, I would go talk to the mechanic who was working on the pump and say, hey, what's going on? How can I help? What do we need to solve? And that was kind of most of how my day was spent, was asking people who were doing the work what issues they were having, and then coming up with solutions. And some of those eventually turned into projects, and helping them do that. And then when my 2 weeks was up, I would fly back in and I would have 2 weeks off to do whatever I wanted. Um, but now that I'm working in the office all the time, it's still pretty much the same thing. It's working with customers saying, hey, what's going on? Are things working as they should? How can we help? And then going about coming up with a solution to help them solve their problems. Just right now, I have a bigger team helping me.
That's great to hear how your role kind of changed over time, but still a lot of traveling and collaboration. And what is one thing that you have done that you're really proud of?
Um, I think raising my kids. I have a 14-year-old daughter and an 11-year-old son, and just watching them do what they do at school, playing sports, all their extracurricular activities, just that really makes me proud, just watching them do what they're doing.
Awesome. And I think that's a perfect way to wrap up our wonderful conversation. So that's all the questions we have time for today. But now we're going to introduce our hands-on challenge. And let's watch this Discover E challenge video featuring Francisca.
Hello, my name is Francisca Ogundele. I'm a chemical engineer at Shell. Today, I have an engineering challenge for you to repurpose your trash. We all know about the importance of recycling, but some engineers are thinking bigger. What if everything we use gets made into something we can use again, so it never goes into the garbage? I'm challenging you to use materials from your household recycling or garbage to design a prototype for something you can use. A prototype is a simple model for testing an idea to make sure it works. Now, as for the materials you can use for this challenge, the possibilities are endless. Here's a list of stuff that usually ends up in garbage or recycling, such as plastic bags, egg cartons, used paper. You get the idea. You will also need items you can reuse to hold things together, like string, ribbons, or old shoelaces. You can also use Elmer's glue or gum tape because they are biodegradable, while other kinds of tape are not. Now, there are a couple of constraints for this challenge. You can only use materials from recycling or garbage that can be cleaned. And the materials must be safe, so they can't have sharp edges or be dangerous to handle. As you brainstorm designs, sketch out a few ideas. Sometimes the hardest step is deciding what you want to make. Do you want to design a game or toy people can play with? How about something for your pet? Or is there a small problem you want to solve, like keeping your stuff organized? Look at the wide variety of stuff in your garbage and recycling. Imagine some ways these materials could be combined into a whole new object. Draw a few designs, then pick one of your ideas and go with it. When you start building your prototype, you might discover that you need to modify your design or rethink how you're using your materials. That's okay. Lots of times, things don't work out as we planned, and we need to make changes along the way. When you're ready, test your design. Did it work the way you hoped? Think about changes to your design, explore different materials, or you can even start over. Engineers rarely get it right on the first try. They learn from their mistakes and keep trying. You can find the written instructions for this activity and many more at discovery.org. Have fun!
So I hope that you all will try the Repurpose Your Trash challenge and share results with us. And with that, we will be concluding this wonderful conversation. So thank you so much, Francisca, for joining us today. And one of my biggest takeaways from our wonderful conversation is to really embrace change, whether it be taking new risks or exploring those unfamiliar avenues. And of course, challenges arise here and there, but if you're curious, you can turn those obstacles into opportunities to learn. So thank you for those insightful conversation. And I'm sure that all of our viewers learned a lot from you today.
Well said, Kavya. It was a pleasure chatting with you, and thank you, Discovery, for the opportunity.
Thank you. And to all of you who are tuning in, thank you for joining us. Be sure to join our next Chats with Changemakers on Thursday, April 27th at 1 p.m. Eastern Time, where we will chat with our next guest, Vanessa Martinez Huerta, a project controls engineer at Bechtel Corporation who helps deliver green energy globally. See you next time.